Good morning, class. We'll start with our final part, which is part number 3 on two-way analysis of variance. Okay, so let's go on part number 3. Okay. In doing a study that involves a two-way analysis of variance, the researcher is able to test the effects of two independent variables or factors on one dependent variable. See the sentence, it's a bit tricky. They say two independent variables on one dependent variable. Okay, so in addition, the interaction effect of two variables can be tested. So the variable or factors are changed between the two levels, okay, two different treatments, for example. So the groups of two-way Anova are sometimes called treatment groups. Okay, two-way Anova has several null hypotheses. There is one for each independent variable and one for the interactions, which means if they have like three groups, so they have a three null hypothesis and three null alternative hypothesis. Okay, this is a table summary, similar to the previous one-way ANOVA, but they have additional values that we need to add on, like A times B, okay, within total. On this side we have like sum square A, sum square B, sum square A times B, sum square error items or within the group. Okay, and degree of freedom A minus 1, B minus 1, A minus 1 times B minus 1. After that, A times B times with N minus 1, then followed by mean square MSA, MSB, MSA times B and MSW, FA, FB, FA times B. So every single things that you need to fill up when it's come to two-way of ANOVA summary table. So if you complete this table, which means you're able to complete the values, the question or the case studies. Assumption. Okay, in order to apply two-way ANOVA, there are some assumptions. So the population from which the samples were obtained must be normally, okay, this one same as the one-way ANOVA, normally distributed. Sample must be independent as well. Okay, variances of population from which the samples were selected must be equal. Okay, and the group must be equal in sample size as well. So these are the assumptions. So if follow this assumption, then you can apply two-way of ANOVA. Example number 5. A researcher wishes to see whether the type of gasoline used and the type of automobile driven have any effect on gasoline consumptions. So two types of gasoline, regular and high octane, will be used, and two types of automobiles with two-wheel and four-wheel drive, so will be used in each group. So there will be two automobiles in each group. Okay, and for the total of 8 automobiles used, using two-way analysis of variance, the researcher will perform the following steps. Okay, so let's see, there's a gas for two-wheel drive and four-wheel drive. Okay, and two types of gasoline, which is regular and high octane. So each they have two types of automobile, which is two-wheel and four-wheel. So both of them, they have two values each. Okay, let's come with the hypothesis. Your first step, definitely you have to come out with your hypothesis. The first hypothesis will be your null hypothesis. First, H0, there is no interaction effect between types of gasoline used and type of automobile a person drive on gasoline consumption. Okay, and for these, the alternative hypothesis will be there is interaction. Okay, they say first no interaction, there is an interaction effect between type of gasoline used and type of automobile person drive on gasoline consumption. Okay, next, the hypothesis for the gasoline types. Okay, this one for the interaction. Now I'll go on with gasoline types. There is no difference between means of gasoline, and then there is a difference between, okay, one is no, and the H alternative will be there is a difference between the mean. And then the last one, type of automobile driven, there's no difference between the means of gasoline, and then there is actually a difference. So when they say no, and the other hypothesis will be reverse of the other one, okay, opposite of the other one. As for the step number 2, obviously you have to identify the critical value. Find the critical value for the each F test. In this case, each independent variable or factors has 2 levels. Hence, it's going to be a 2 by 2 ANOVA table is used. Factor A is designated as gasoline type and is as 2 levels, regular and high octane. Therefore, alpha is equal to 2. And then, sorry, A equal to 2, not alpha. A equal to 2. Factor B is designated as an automobile type. It has also 2 levels. Okay, therefore B is equal to 2. So the degree of freedom for each factors are as follows. So let's see. Factor A, DFN. DFN is equal to A minus 1. 2 minus 1 is equal to 1. Factor B will be DFN. B minus 1, which is 2 minus 1 will be 1 as well. So the interaction between A times B, A minus 1 times B minus 1, you will get 1 times 1, you will get 1. Within also A times B. A times B is 2 times 2, 4. 4 times 1 is equal to 4, where N is the number of data values in each group. Okay. N is the number of data in each group. So in each group, the number of data is 2 over here. Okay. Next. So the critical value for FA test is found by using alpha 0.05, DFN1, DFD 4. So in this case, FA will be 7.71. Okay, so it's gonna be 7.71 for this case. So the critical value for FB test is found using alpha 0.05, DFN 1, and DFD is 4. Also FB is 7.71. So critical for FA times B will be found by using DFN N1 and DFD is 4 as well. You will get same value, which is 7.71. So if there are different levels of factors, the critical values will not all be the same. So for example, if factor A has 3 levels, factor B has 4 levels, and if there are 2 subjects in each group, then the degree of freedoms are as follows. So we have DFN with A minus 1, 3 minus 1, and then DFN B minus 1, 4 minus 1. After that, DFN A minus 1, B minus 1 times, we'll get 2 times 3 equal to 6. DFN, which is AB, times with N minus 1, you'll get 3 times 4, 12. 12 times 2 minus 1 is 1, is 12. Okay, so we are done with CV, critical value. We'll compute the test value now. So based on the test value will be calculated based on the formula, and the values are, we almost get it. So sum square will be 3.920 divided by 2 minus 1, which is 3.920 as well. MSB will be 9.68. Okay, they already give the formula previously, so you guys, I hope you guys can recall back or check back. Okay, the sum square of factor B, sum square of factor A and all. Okay, okay, 9.680 divided by 2 minus 1, you'll get 9.680. So MS, you mean square for A times B, you'll get S as A times B divided by A minus 1 times with minus A minus 1 times B minus 1. So you will get 1 times 1, 54 divided by 1, you'll get 54.8. So MSW 3.3 divided by 8 divided by 4, okay, you'll get 0.825. So this is for the mean square. Okay, next for the F values. So each F value will be divided by MSA divided by MSW, MSB divided by MSW, MSA times B divided by MSW. So all these values you got. As for the DFN, DFN and DFD as well. So based on this, we will referring and write everything in the table. So you just fill up the table. Gasoline A, automobile is B, interaction A times B within. So all the values just fill up. Once you fill up, so you know what are the values. So degree of freedom 1, 1, 1, 4. Okay. And then mean square also we already calculated. So just apply and then followed by the F value. Okay, followed by the F value. So make the decision since FB is equal to 11.733 and FA times B is equal to 65.52 are greater than the critical value of 7.7771. The null hypothesis concerning the type of automobile driven and the interaction effect should be rejected. Since the interaction effect is statistically significant and no decision should be made about the automobile type without further investigation. So summarize. So in this case, we just summarize the result. Since the null hypothesis for the interaction effect was rejected, it can be concluded that combination of type of gasoline and automobile does affect, yes, it's affect the gasoline consumption. Okay, so that's all for part 3, which is two-way of Anova. By the way, we are done with chapter 3 class. I will share the revision exercise for chapter 3, so hope you guys after watch the video can do the question and submit. Thank you.